Now we are going to see the propagation of light in optical fibers. So see this diagram. This is the ray 1. This is the incident ray, assume. It is reaching at point A and is traveling along AB. This is traveling along AB and BF and so on. This is yet another ray, ray 2. It is reaching D and is traveling along DMUT. So these are the wavefronts. AE and DB are the wavefronts. This is the S1 is the distance traveled by AB, this ray, between this plane, AE plane and DB plane. And this S2 is the distance traveled by ray 2 between this AE plane and DB plane. So, this is the explanation. We have taken two parallel rays R1 and R2. They are launched inside an optical fiber. So, this is the core material. Surrounding you have a cladding material. The refractive index of core is N1. The refractive index of cladding is N2. Next, the diameter of the core we take as D. The phase front or wave front. What is wave front or phase front? Locus of point having the same state of vibration is called phase front. So, this wave front AE. See, this is your phase front. This AE is common to this ray as well as both ray A1 and ray 2 and phase front DB. DB is common to ray 2 and BF. See, DB is common to ray 2 and this BF. This AE is common to ray 1 and this ray. So, ray 2 is common to both the phase fronts. See, this is your phase front. This ray 2 is passing to this phase front, and this is at another phase front. Ray 2 is reaching here. So it is common. Ray 2 is common to both the phase fronts, we say. So next we should get a bright spot of light. This bright spot of light should occur. How it occurs? Due to constructive interference only it occurs. So if both the rays are meeting at the same phase means constructive interference will be occurring. So what is the condition for constructive interference? The distance between these two phase fronts must be multiples of 2 pi. In other words, the phase change undergone by ray 1 in travelling distance S1 and ray 2 in travelling distance S2 must be 0 or multiples of 2 pi. So this is the S1 distance. This is the S2 difference. So between these two wave fronts, this S1 difference between this phase difference between S1 and S2 should be 0 or multiples of 2 pi. So we should find what is S1. S1 is equal to d by sine theta as per by using a trigonometric formulas. S2 is equal to AD cos theta. So this is given. Then what is this is the path. S1 and S2 are the path in travel. So by using that I am finding the phase difference. What is the phase of corresponding to the path S1? That is equal to 2 pi n1 by lambda into S1 plus 2 delta. So what is this 2 delta? It is the phase change undergo by ray 1 when it is subjected to total internal reflection. It is the phase change undergone by ray 1 when it experiences total internal reflection. Similarly, what is phi 1 and what is phi 2? Experienced by the ray 1 in traveling S1. The phase change experienced by the ray 1 in traveling S1. Phi 2 is the phase change undergone by ray 2 in traveling S2. So you should find the difference, phase difference, phi 1 minus phi 2. That should be equal to 2m pi, integral multiples of pi. If this condition is satisfied, means constructive interference is going to happen and the wave will be propagating, we say. So what is the value m? M can take discrete integer values. So because of m is taking a discrete integer values, the theta value should also be discrete only. So only there are discrete launching angles we say. So within the acceptance cone of the fiber, there are certain discrete launching angles depending upon m. So the acceptance cone is neither a solid cone of rays because at certain discrete angles only light can propagate we say. So it is no longer solid cone of rays. Hmm? So it is an annular conical ring of rays we say. So if the condition, that is, this condition has to be satisfied. If this is satisfied means the light will be propagating. So it is annular ring of different modes I say. So this is one ring, this is another one ring, this is another one ring. So this is m is equal to 0 we can take. This is m is equal to 1, m is equal to 2 and m is equal to n so on. So within this rings if light is launched means we say it is a annular ring of different modes. But between this m is equal to 1 and m is equal to 2, if light is launched means it will not propagate inside the fiber. So that phase condition phi 1 minus phi 2 is equal to 2 m pi should be satisfied. If it is satisfied means you'll be getting m is equal to 0 or m is equal to 1, 2 and so on. Then with respect to wave theory, how light is going to propagate, because I have considered light as a transverse electromagnetic wave. So inside the fiber, either meridional rays or your skew rays is going to propagate. So what is meridional rays? So whenever that ray is striking along the axis of the fiber, I say it is a meridional rays. So when it propagates, the E component, that is the electric and magnetic field of the rays, can superimpose and they can yield either transverse electric or transverse magnetic waves. So what is the subscript X? It defines the number of maxima and minima in the resultant light intensity pattern we see. So see this diagram. This is the incident ray. This is your incident ray. This is your reflected ray. Actually, this reflected ray, as it propagates, strikes the axis. Then once again, it will be reaching this point. It will be internal reflecting and moving on. This is called meridional rays we say. Next, what is Q rays? See this diagram. See, this is the incident ray. The light is moving in a helical path. See, this is the helical path. So this is a cross-sectional view. So this is a gamma is the reflection. It is undergoing with respect to this normal we say. So the total angle change as it undergoes reflection, total internal reflection is 2 gamma here. So what is Q rays? That is the rays that propagates in helical path is called skew rays. So this skew rays propagation results in a form of modes. This is neither transverse electric or transverse magnetic in nature. So the name of it is called hybrid modes we see. So this is also present inside a dielectric waveguide. Then what is this order of this mode? Actually, this is the lowest order mode that can propagate inside the fiber. So we can assume that this lowest order mode contributed from the skew rays is propagating along the axis of the fiber. We can conclude. Next, what is an acceptance angle? So this theta A is called the acceptance angle. So it is a maximum angle to the axis. It is a maximum angle to the axis at which light ray may enter the fiber in order to be propagated. So whenever I am launching a light, it should lie within this acceptance angle, either theta A or within this cone. Only then light will be launched inside the core of the fiber. Suppose light is present here means it will not be launched inside the fiber. So whenever I am launching a light, it should lie within this acceptance cone. This is the acceptance half angle we see, theta A. So when it is within the acceptance angle only, light will be propagating inside the fiber. Otherwise, it will not travel inside the fiber. Next, numerical aperture. So it is a light gathering capacity of a fiber. So the formula for it is this: Na is equal to N naught sine theta A. It can be written as root of N1 square minus N2 square. This N1 and N2 are the refractive index of the first medium, second medium. N naught is for air, its value is 1. This theta A is the acceptance angle. Then this can also be written as N1 into root of 2 delta. So what is delta? Fractional index difference. How it is calculated? N1 square minus N2 square by 2 N1 square. That is approximately equal to N1 minus N2 by N1. So this delta value is very small, is less than 1. This is called the numerical aperture. Thank you.